Rule, because last time we already studied the addition, subtraction, multiplication, and the exponents. Now we want to know about the
Yeah.
divisibility rule. Okay, for grade 6. Alright, so divisibility rule. Divisibility rule is actually inside the number theory. The number theory is like an okay, it's like we have number theory, we have geometry kind of thing. So we study this divisibility rule because we want to check quickly.
Divisibility?
Yeah, divisibility rule. Divisibility rule is the rule that we just want to check that fraction is divisible or not, like or the yeah,
Oh, okay.
or the one number can divide by another one number or not. That's why we studied this divisibility rule. For example, like sometimes we just want to notice quickly that is this divisible or with remainder. Now we will have the rule. We know that maybe 12 divided by 2, but why? But why? So now we know the why. So
Yeah.
divisible by 1 by okay. So first of all, divisible by 1. What number can divide by and that can be divisible by 1? What?
Any number is divisible by 1, but it was just gonna result to the same thing anyway.
Yeah, yeah. So for divisibility of 1, any number like any number can divide can wait, any number I will put it here. Any number can divide
Divide?
by 1. I use too much of my word like lately, so sometimes it's very difficult to figure out the English number. For example here. Okay, I think we don't need to have a lot of example. Like any number can divide by 1, which result of that number again. Even 1 divided by 1, it's equal to
1 divided by 1 equals to 1.
the 1. Yes. Okay, so we don't need to detail. Continue. Divisible by 2. Okay, so what we know that the number that is multiplied by 2 is also divisible by 2. Like for example, the timetable of the 2. For example, the timetable is 2, 4, 2 by 1 is 2, 2 by 2 is 4, 2 by 3 is 6, 2 by 4 is 8, 2 by 5 is 10, 2 by 6 is 12, 14, 16, 18, 20, 22, 24, 26, 28, 30. All of these numbers are divisible by 2, right? Because it's multiplied by 2.
Yeah.
And if we divide by 2 back, it will result like here. If we divide by 2, it will be give the result is 1, 2, 3, something like that. But now, do we see the pattern here?
Yeah.
So the
The
part,
pattern is
yeah,
the
this number, right?
yeah.
So the pattern we always see like a 24680, 24680, 24680. So when we see the last digit is
An even number.
4, 6, 680 always divide by 2. Always can divisible by 2. But we also know that 24680, when the last digit is 24680, we call it as the even number, right?
Yeah.
But that's why we can conclude that all even number are divisible by 2. All even number are divisible by 2.
Yeah.
Okay. For example, okay, let's give one example. One example. Do you think 13647 4 this number, will it be this divisible by 2 or not?
No. Well,
Yes or no?
yeah.
One, yes, because it's end with 4, which is even number. So all even number is divisible by 2. So next time when we have for example, when we go to fractions, if we have these kind of number, we know that this will be the whole number. It's not a fraction anymore because it can be divisible.
Yeah.
Next one is divisible by 3. So we study divisible by 1, divisible by 2, now divisible by 3. If we have, for example, we know that any number that multiply by 3 can divide by 3, right? Multiply by 3, it's divide by we can divide by 3. So from the timetable, when 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 12, 15, 18, and then 21, 24, 27, and 30, and then like 33, and continues. Do we see the pattern like divisible by 2? Is there any pattern here?
No, because they're not divisible by two.
Yeah, yeah. Now we want to like seek for the conclusion. What can be divisible by 3? From 2, we can see the pattern that it's go like 24680, 24680, 24680 again and again. But for 3,
No.
there's no pattern, right? We cannot see the pattern like which can be divisible by 3. But then after a lot of number, we notice that this number is 3, this is 6, 8, but this, when we add these two digit number, 1 plus 2 is equal to
Three.
3, and this number, when we add the two digit, add all those digit, 1 plus 5 is equal to
Six.
6. This number, 1 plus 8,
Nine.
9. How about this number? When we add those digits,
Three.
3 plus 3,
Three.
3 plus 3,
Oh, three plus three equals six.
6. Yeah. This, when we add is all those 3. Then we notice that if we add those digits together, it's always 369, 369. When we
Yeah.
sum all the digits, it's always 3, 6, and 9. So then we realize that is it really happens? So we give another example. Example 1, 2, 6. So this number, when we add together, it will be, when we add all this number 1, 2, 6, it will be 1 plus 2 plus 6 is equal to
Uh, 9.
9. Yes. Now we know that this sum of all digits equal to 9, which may divide by 3 or not. So then we check the result. Is it really happens? Because we know that this, when we add together, it's always give the result 369, 369. But now we want to see the large number. Will this divide by 3? So when we have 126 divided by 3, is it divisible or not? So
Yeah.
3, two
Oh,
numbers. So 4 times 3 is 12. And then this is 0. We drop the 6. So 2. 3 times 2 is 6. So this is 0. Mean
so it's 42.
42. That is correct. So we can conclude that the sum of all digit number, all digits and divisible by 3, then this number is divisible by 3. By 3, we have 4, it's divisible by 3. Did you see the conclusion? Did you get the conclusion?
Yeah.
So when we add the number, all the digit number can be divisible by 3. We know that that number is divisible by 3. Can you give one example of a large number that can be divisible by 3? Any large
Um,
number that can be divisible by 3.
963.
100,
No, I said 963. But
963. Yes, that is can be divisible by 3 because 9 plus 6 plus 3 is equal to
18.
18. And 1 plus 8 is equal to 9, so that is divisible by 3.
Yeah.
Yes.
And also for
Have you ever studied about this divisibility rule or the D1 terms?
I think we have in the past.
Okay, so maybe this just for the a little bit review of then, so that when we comes to the fractions, the integer, it's very easy for you. Then, okay, now we have the divisible by 4. Okay, what are the number can be divisible by 4? It's the for multiplication, right? So when we for multiplication of the 4, it's 4, 8, 12, 16, 20, 24. All these number can be divisible by 4.
4.
32 plus 36, 40, and then continue like 44s and so on. First of all, do we see the pattern of this number? Um,
Yeah. Wait.
which is what is it go bigger and bigger? It's like 48 and then like 52 and then 56 and then 60, 64, so 4 and so on.
Yeah.
There seems to be like a here 4, 8. 12, or maybe 2, 6, 0, 4, 8, 12, 4, 8, 2, 6, 0, 4, 8, 2, 6, 0, 4, 8, 2, 6, 0. It's look like that.
They all end with 0,
2, 6, 0.
6, 0, 4, and 2,
Yes, it
right?
always end with 48260. But then we just want to have, like, for example, we have, if we have a big number, for example, 152, will this divisible by 4 or not?
No.
Then we can check. So when we divide by 4, it will be 3. 3 times 4 is 12. So this gives 3 and 2. And then it's,
Oh, it is.
it is, yes. 8 times 4 is 32. Then it is 0. Oh, this is nice.
My bad.
What if we know that it's end with 4, H2 6? So what is it end with 4? What is 154? Now it's end with 4. Will this divisible by 4?
No.
No. Okay, but check. We can check. We can always check. So 3 times 4 is 12. And then we have 3 and 4. So it will be like 8 and 32. And
And there's a remainder of 2.
remainder of 2. Then we cannot conclude the pattern is always end with 48260, right? But then
Yeah.
the rule said we notice not just one number, one last digit number. We notice the last two digit number. If that number is large, for this two digit number is already two digit number. But if it's large number, 4, 5, 6, 7 digit number, we notice two last digit number. If the two last digit number is divisible by 4, then the whole number is divisible by 4. Example.
So if the last number is divisible by 4, every number is divisible by 4.
The
I mean the
last
number.
two digit number, for example, last two digit number, let's say, okay, I will delete this first. The last two digit number, for example, 1, 2, 3, 4, 5, 6. Last two digit number divisible by 4 should be this. Okay. Well, so we know that 12 is divisible by 4, right? So we
Yeah.
don't care whatever happened before that. Even this slide number, this is slide number, right? It can be like 12 million something, it's a light number. So whatever happened before the last digit number, we only care about the last two digit number. If these last two digit number can be divisible by 4, then this whole number can be divided by 4. Okay, then we can
Okay.
check. So if like 12,345,612, is it really happen as in the rules? So then 3 times 4 is 12, and then we have 0 here, drop the 3. We cannot divide by 3, so we add 0, we drop another 1, which is 4. So 8 times 4 is 32, and then we have 2 here, drop the 5. We have 6 times 4, 24, and then we have 1, and we drop the 6. So this is 4, 4 times 4, 16. 0. So we drop 1, cannot divide, we add 0 and drop the 2, and then we have 3. Right? So then it's divisible. Then we can conclude
Yeah.
that this rule is correct. Sorry. So we always notice the last two digits number. If the last two digit number is divisible by 2 or divisible by 4, divisible by 4, therefore, as you see this sign,
Therefore,
therefore
the
these
equal
whole
sign,
this sign, it's look this wait. The sign look like this.
like the number that's like less than.
This is like therefore this sign.
Okay.
But we in typing there's no such that, so we use equal and then the like the bigger bigger comparison. This it's look like this,
Okay.
and this mean therefore. Wait, I will delete this first. Therefore it's therefore it can be divisible by 4. Now, can you give the example of any large number and it can be divisible by 4?
And I can use any number
Yeah,
that isn't divisible for the
I
last
mean,
two.
yeah, any number that is divisible by 4, but it's large number, not just 2.
13, 15. Wait, 13,100. 12. 112.
Yeah, like that. Yeah, this is divisible by 4 because the last two digit is divisible by 4. Can you give another one?
Well, 500,000. 68.
568. 568,000.
68,000. 1,600. Wait, 116. 016 after.
016, yes. Oh, it is also divisible by 4. What if it's this number, 000? Will this divisible by 4?
No. Wait.
We notice two
Yes.
last digits. So 00, can it divide by 4?
No.
No or yes? When 0 divide by 4, what is the result?
Wait, yes, because
Yes.
4 divided by 0 is 0, right?
0. Yes, yes. So 0. So this number also divisible by 4. Can be divided by 4. Okay. Okay, now
Can we divide?
mhm.
Yeah.
Okay, now you get it. So we move on to next one is divisible by now 1, 2, 3, 4. Now divisible by 5. Divisible by 5. This is not very hard. This is quite easy for divisible by 5. So when we use the multiplications table of 5, then we know that all the number on the uh, multiplication table will be divided by 5. So it's 5 one time is 5, 5 two time is 10, 3 time, 4 time, 5 times, 6 times, and it continues. this 45, 50, 55, 60. So do we have the pattern here?
Mm, yeah, because they're either zero or they either end with zero or five.
Yeah, it's either ends with 0 or 5. So all the number that have the last digits is 0 or 5, it will be divisible by 5. But do we
Yeah.
really believe that? Maybe. So,
Oh yeah.
yeah, sometimes it's already we already seen the pattern, but we're not sure like we should believe or we should not. So, let's give a very big number that is either end with 0 or end with 5, and then we start to divide. Is it really correct by the rule?
Okay.
Can you give any large number that end with either 0 or 5?
35,260.
260. Okay. So this,
200.
as,
No. Wait.
as,
Yeah. Yeah. Yeah.
yeah, as we noticed, it's end with 0. So we quite knowing that it will be divisible by 5, but we still not believe that, so we give the random example and make a divisions. So divide by 5, so we need two
30.
digits, so 7 times 5 35 0, so we drop the 2. What's next?
Then we try to. There's nothing to subtract this, so we subtract it by zero, and then we get the answer two. Then put on six.
Before
No.
put another 6, what should we do?
Subtract it by zero, because there's nothing to subtract it by.
Yeah, nothing to subtract by, so we add 0 here, right? Now 2 is smaller than 5, so we add one more 0, so we can drop another digit, right?
And then we subtract that by 25.
Yes, so we have 5 times 5 times 5, 25. Then it's 1, then we drop the 0, we get 2. 2 times 5 is 10, so this is 0. Then
And
it
then
is
we.
divisible, so that is correct, so the rule is correct. So any number that's last digit is either 0 or 5. Therefore, that number is divisible by is divisible by 5. So any number that have the last digit is 0 or 5. Therefore, that number is divisible by 5. Okay.
Yeah.
Next one is now divisible by 1, 2, 3, 4, 5, 6. Divisible by 6. Okay, so we let first of all, if we want to know any number that is divisible by 6, we check the pattern first. If there any pattern, we use that pattern immediately. If there's no pattern, we need to see like what is, what if, what is, and then we can know the result. So the time about 6 multiplied by 6 is 6, 6 multiplied by 1, 6 times 2, 12, 18, 24, 30, 36, 36, and then 42, 48, 54, 60, and then 66, 72, 78, 84, and then 90. Do we have any pattern here?
Um, they all went. They all end with 6, 2, 8,
Six,
4, and 0.
2, 8, 4, and 0. 6, 2, 8, 4, 0. 6, 2, 8, 4, 0. Okay. But now, what if the number equal to. Now we see the pattern, but we don't believe. We still don't believe that that
Yeah.
pattern is work or not. So we give a random example. For example, it's end with 6, or end with 2, or end with 8, with 4, 0. Can you give any random number?
42,432.
32,
Wait, no. 62.
60,
62.
62. Divide by 6. So then when we divide by 6, this is how many times?
Uh, 42, right?
Yes, 42. How many times 6 go to 42?
7.
7 times 6 is 42. 0. So we have 4 here. So 4 is smaller than 6. So we add another 0 to drop another 1. 60, 46. So how many times 6 go to 40?
7.
7 again. Yeah. 7 times 6 is 42. And this is 4 and 2 drops. So it's
So it's divisible. Oh, well,
7 again.
7, but it's divisible by 2.
Yeah, now
And
it's
why
divisible by 6. Remember,
6?
zeros
Oh,
are
divisible.
divisible, right? So, but
Yeah.
what if that number, we know that it's ended 0, 6, 2, 8, 4, 0. What if this number, again, but we
Mhm.
change the 2 to 0, will this divide by 6? Divisible
Yeah.
by 6. Okay. So now, why don't we try one more times? 7 times 6, 42, and then this is 0, so we drop the 4, we get 0, we drop the 6, and we get 7, 7, 6 times 42, and then we have 4 and 0. And then how many times 6 to go to 40?
40 is 36 or 6.
6 times 6 is 36, right? So 40 minus 36 is 4.
4.
So
It's
remainder,
not?
yeah, remainder is 4. So why this and with 2 and it's divisible? Now and with 0 is not divisible by 6. Then we realize that no, we cannot use this pattern like n with 0 or n with 2.
So they're not always divisible by 4? I mean by 6?
6. This pattern is not always divisible by 6. This is not. So, but then, like this scholar, like we still notice that 6 is the combination of what number and what number. 6 is
Oh,
the combine of 2 and 3, right?
2, 3. Yeah.
Yeah, it's actually this is called compound number. Compound number. 2 and 3 is called prime number. We will go to that in the detail, but this is a compound number.
Okay.
Compound number is combination of two number, which is from 2 and 3. So 2 times 3 is 6. So then we know that, do we have the rule that is divisible by 2?
Divisible
Yes.
by 2.
Right.
Yeah.
And do we have a rule that is divisible by 3?
Yeah.
Yes. So if that number combine, if that two rule combine, will that divisible by 6?
I thought it would be,
It could be
but
okay, but we still don't believe, right? You thought maybe, but what if? What if? We don't know. So
divisible,
let's check.
divisible by 2, divisible by 3, divisible by 4, divisible by 5.
Yes,
And what?
we're not sure. So we need to check. So if it divisible by 2 and divisible by 3, oh, here, divisible by 2 and divisible by 3. So the number that is divisible by 2 and divisible by 3, we know the rule that divisible by 2 unless the number is
Unless the number is a compound number?
6 is a compound number of 2 and 3, right? So when it's when we apply these two rules together, will that divisible by 6? We thought that maybe it will be divisible by 6, but now let's check together that if we combine those two rules, will that divisible by 6 or not? Okay,
Okay.
but by the rule, what number can be divisible by 2?
Divisible by 2,
Yeah,
42, 36,
yeah, or that
4.
number is
Divisible by 2.
even number, is even number, right? The condition,
Okay.
the condition that is divisible by 2 is all even number. How about the condition that is divisible by 3?
They are not even numbers. Wait, no.
It can be even number, but
It can be even numbers, but like a mix of like even and odd.
yeah, it's mix of even and odd, so it's even and odd number. The rule is here, right? The sum of all digits are divisible by 3, right?
Yeah.
Sum of all digits and divisible by 3. So if we mix these two conditions together, the sum of all digits are divisible by 3 and it's even number. So can you give any
Mm,
random number that's following this rule? And then we check is it
that's following the number 3 rule. Rule number 3.
uh, the
The
line of 2 and 3. So the condition that is divisible by 2 is all even number, right?
yeah.
And the condition that is divisible by 3 is the sum of all digits are divisible by 3.
24, 24,000,
Like
24,000,
24,000,
um, 30, uh, 0, 30.
30. Okay, so we checked. First of all, it's
Wait, no.
even number, correct? Because it ends with 0, it's even number. The sum of all digits will be 2 plus 4 plus 0 plus 3 plus 0, which is 6, 9. So it's divisible by 3. So complete these two condition. Okay, so this number is complete these two condition. Now we want to check if that complete these two conditions, will that divisible by 6 or not.
Okay.
So let's check. Uh, how many times 6 go to 24?
4.
4. 6 times 4 is 24, so it will be 0. So we drop another 0 here. Uh, don't have, so put another 0, drop another 1, which is 3. Here cannot be divided, so we add another 0, we drop another 0 here. So how many times 6 go to 30?
5.
5. So 5 times 6 is 30, that is 0. So if that complete this condition and this condition, one example is already divisible, right? It's end with zero, so it's divisible.
So basically, it has to uh, complete the regulations of even and sum of all three. You know.
Yes, but now we still don't believe, right? Because we only have one example. So can you give another random example to make sure that we should use two example before we give the conclusion?
Uh, even 25,000. 624.
624. Okay, so first of all, it's even number, correct? And the sum of all number will be 2 plus 5 plus 6 plus 2 plus 4, which is 7, 8, 4. So this is 15 plus 4 is 19. 19, will this divisible by 4 by 3?
Divisible by 3? Yeah.
But this
3.
number is not divisible by 3.
No. Yeah, no.
So we haven't complete those condition yet.
Okay.
So what number should be the sum of all digit is divisible by 3 and it's even number? Maybe
Um, 60, 25, 24.
60, 25, and 60,
Uh,
25, and
24.
24. So first of all, it's even number, correct? The sum of all digit is 6 plus 0 plus 2 plus 5 plus 2 plus 4. Okay, 6 here, this is 6, this is 7, this is 8. 6 plus 7 is 13. 13 plus 8 is 21. Okay, so this is divisible by 3. So
3.
it's complete both condition. It's even number and sum of all digit is divisible by 3. So let's check if that divisible by 6 or not before we go to
Okay.
the conclusions. So 6 times 1 is 6. So this is 0. We drop the 0. Still cannot divide. So we drop another 1. It's 2. Still cannot divide. So another 0. We drop another 5 here. How many times 6 go 25?
6 goes into 25, like 4.
4. 6 4 times 24, right? So we have 1, 2 drop here. So
So, so it's
2,
divisible by 3. Oh, well. So 2, and then we
so
drop 6.
2 times 6 is 12. This is 0 and
0, and then you.
this is 6 or 4. 4. Oh,
Hmm?
why is still not?
Huh?
6025. Oh, it's still not. Why? Wait, 607.
Is this the first time this has happened for you?
Yeah, it's
Or
the first time that it's still like not divisible by 6. Why? Because we complete the condition already, but why still not?
national discovery?
Yes, now we need to discover. 6, this is 7, which is 13, 13. Oh, this is 6, not 2 plus 4 is 6. So 13 plus 6 is 19. This number is not divisible by 3. First of all, this
Oh,
number is not divisible by 3. Oh, I thought math is wrong, but now, no, we are wrong. So this number is not complete the condition of 3. because this is
60, 25, 25. Wait, 23. Wait, wait.
this if it's with the
60,
last number,
25.
let's
Mhm.
say what 6. What number do you prefer?
60, 24, um, 22. Wait, 20, 20, 60, 21.
20.
Okay, now I'm confused.
Okay, take it slow. 60.
60,
What? 60.
60, 60,
Yes.
21, 12.
21, 12. So, yes, it's even number. First of all, the sum of all digits will be 6 plus 0 plus 2 plus 1 plus 1 plus 2, which is 6, 3, 3, which is 12. So it's divisible by 3. So it's complete. Now it's complete those two condition already. So now let's check it's divisible by 6 or not. So 1 times 6, we have 6, 0, and we have 0. So 0 times 6 is 0. We drop the 2 still. So we add another 0. We drop the 1. 6 times how many to go 21? 6 times.
21. It's 3.
Yeah, 6 times 3 is 18. So it's 3 here. We drop the 1 here. How many times 6 go to 31?
5.
5, yes. 5, 6 times is 30. So we have 1 here, drop the 2. How many times 6 go to 12?
2 times. Wait,
That is correct. 2.
yeah.
2 times 6 is 12. So that is terminated. 12 minus 12 is 0. So that is divisible by 6. Now,
Yay!
yeah, now we have two example that is divisible by 6. So we can come to conclusion that when it's applied those two conditions, when it's even number and the sum of the digits is equal to 3, so that is the okay, finally we made it.
We can conclude that we are done and that we hate the divisible by 6 rule.
Okay, okay. Just we give the mistake, like we give the incorrect example. That's why it's take a little times. So coming back, so divisible by 6, if it's worked for 2 and it's worked for 3, meaning that it's even number and sum of all digits are divisible by 3. Therefore, or we can write a sign. Therefore, that number is divisible by 6. Now we can come to the conclusion. Is it work for 2 and 3? Then it's divisible by 6. Okay, so since I think it's times already, but tomorrow we will continue with 7, 8, and 9. 7 is quite challenging, so let's do it tomorrow.
Okay, so let's wrap it up and see you tomorrow.
Okay, so let's cut it and see you tomorrow.
Bye.
Yes. Goodbye.